So this is a new chapter, carbonates. First, limestone. Basically, what is a limestone? Limestone is calcium carbonate, CaCO3. And this limestone, calcium carbonate, in a lime kiln, it decomposes to calcium oxide and carbon dioxide. So basically a thermal decomposition reaction occur if we have calcium carbonate, which is CaCO3. It decomposes into calcium oxide plus carbon dioxide. The states calcium carbonate is solid, calcium oxide is solid, carbon dioxide is gas. So what is the simple structure of this lime kiln? This is the structure of the lime kiln. So in this lime kiln, the furnace is at a high temperature and we add solid calcium carbonate, the limestone, CaCO3. So when we add this solid calcium carbonate, the reaction is known as a thermal decomposition because by the action of the heat, we are forming a product. So the solid calcium carbonate, which is added to this furnace at a high temperature, what it causes a decomposition. It will decompose into two things. One is calcium oxide. Calcium oxide is a solid. So at the bottom, what we will receive, we'll receive calcium oxide because it's a solid. So when calcium carbonate is added, that decompose into calcium oxide, which we obtain at the bottom. And the carbon dioxide gas is there, which is released and it will leave the furnace because we are not using carbon dioxide. We have the uses of calcium oxide, and this is known as lime kiln. Is it clear? Then what you have to learn the uses of calcium carbonate, where we use this calcium carbonate. Calcium carbonate is used for manufacture of extraction of the iron, which we use. This calcium carbonate was added, which form calcium oxide and carbon dioxide, and that calcium oxide was reacting with silicon oxide, which forms slag. So the uses of the calcium carbonate, it is used in extraction of the iron. So we use calcium carbonate for extraction of iron. It is also used in manufacture of cement production. For production of the cement, we also use this calcium carbonate. And this calcium carbonate is also used for treatment of acidic waste, or treatment of soil, or just now we discussed for water, acidic soil or acidic water is there. These are some uses of calcium carbonate. Then as the calcium carbonate it decomposes into calcium oxide and carbon dioxide. What we call this calcium oxide is known as quick lime. Lime, or you can also say quick lime. So basically, what is lime or quick lime? Calcium oxide is the lime or the quick lime, and how it is formed? It is formed by thermal decomposition of calcium carbonate. So the thermal decomposition result in a formation of calcium carbonate, result in a formation of calcium oxide, like CaCO3 by the action of the heat produce calcium oxide plus carbon dioxide. Appearance, what is the appearance? It is a white solid. Calcium oxide, calcium carbonate is also a white solid, because group 1, 2, and 3, their compounds are white solid. What are the uses? It can be used for desulfization, of flue gases. Desulfization means removing the sulfur. How it is removing a sulfur? Because what happened? Calcium oxide is base or basic oxide. And the flue gases, like example, the industry, if acidic gas is given off, these gases which are given off in the industry are flue gases. So it can remove the sulfur from that. How it can remove the sulfur? Because if sulfur dioxide is there, sulfur dioxide will be acidic. So one is basic, another one is acidic, so they can react with each other. So as they can react with each other, it will form a compound, and that will remove the sulfur, like does not allow the sulfur to escape to the atmosphere, so it will not cause an acid rain. It can also be used for treatment of acidic soil as well. But it is not effective as compared to calcium carbonate. Calcium carbonate is more effective because calcium carbonate is insoluble. This calcium oxide is sparingly or partially soluble. The third one is known as a slake lime. What is slake lime? Basically, a solid calcium hydroxide is known as a slake lime. And how it is formed? When calcium oxide mixed with small amount of water. Very small, like drops of water are added. So what it result? The calcium oxide, which is solid, mixed with a small amount of water. This will result, because the water is not that too much water is there, it cannot dissolve this. So what will form? It will form calcium hydroxide, but that calcium hydroxide will be in a solid state. What we call that as slake lime. And what is lime water? The lime water is aqueous calcium hydroxide. The aqueous calcium hydroxide is known as a lime water, and how it is formed? When calcium oxide mixed with excess of water. Like if we use too much water, then what it result? The calcium oxide, it is sparingly soluble. So if we add too much water, what is there in a liquid state? Calcium oxide in a solid. But now we are using more than enough, like too much water. So what it result? This will also result in a formation of calcium hydroxide. But this calcium hydroxide is aqueous. What we call that as a lime water. And here this is a solid. So what we call slake lime. So if we have, like example, if this was calcium oxide, so how slake lime is formed? Like adding a drops of water. So when adding drops of water, it will form calcium hydroxide but remain solid. We call slake lime. But how calcium oxide converted into calcium hydroxide aqueous? By adding too much water or dissolve in water. When too much water is added, this is sparingly soluble, like it will dissolve. And when it will dissolve, the solution will turn into aqueous calcium hydroxide, which is also known as a lime water. So there's a small difference between a slake lime and the both compounds, the chemically both compounds are same, but slake lime is a solid calcium hydroxide, where lime water is a soluble, sparingly soluble calcium hydroxide. And how a lime water turned milky when tested with carbon dioxide? Or why the lime water will turn milky when tested with carbon dioxide? So basically, what is lime water? Lime water is aqueous calcium hydroxide. When we bubble carbon dioxide, when we pass carbon dioxide, what it result? This result in a formation of calcium carbonate plus water. What is this calcium carbonate? This calcium carbonate is solid. So due to the formation of this solid, what we observe? We observe that the lime water will turn milky. So this lime water is calcium hydroxide. When we bubble or pass carbon dioxide, this result in a formation of solid calcium carbonate and the lime water, that particles of the calcium carbonate, because they're white in color, so that what they make the solution milky or chalky, you can also say. Is it clear? The carbonate topic. This is the only carbonate topic. It's not having too many details. You just have to learn the uses of calcium carbonate and calcium oxide and how they are formed, the difference between the lime water, slake lime, what is quake lime, and what is calcium carbonate. Now some questions related to this topic. Uh, Question one, when limestone is heated, it form a lime, calcium oxide, and carbon dioxide. Which statement is not correct? Which statement is not correct here? Look, the first one, carbon dioxide is a greenhouse gas which may contribute to the climate change. That's correct. Slake lime, lime water, slake lime, calcium oxide, they can be used because they are hydroxide. Like what is a slake lime? Slake lime is calcium hydroxide. So calcium hydroxide can react with acid and it can neutralize that acid. So this statement is also true. It can neutralize the industrial waste. But if you check statement C, lime can be used to treat alkaline soil. Like if the soil is alkaline, how the lime will react? Example, there's a field which is having an alkaline soil. Alkaline soil means the pH is more than 7. If pH is more than 7, it is alkali or base, and I'm adding calcium oxide. So calcium oxide cannot react with an alkali, it can only react with acid. So there is no reaction between calcium oxide and alkali. So if there is no reaction, how it can be used to treat the alkaline soil? So C is not the correct answer. This reaction is example of thermal decomposition. That's also true. One reactant form more products by the action of heat. Is it clear why the first one answer is C? Because the lime is a calcium oxide and calcium oxide is a metal oxide. Metal oxide can react with acid, they cannot react with base. That's why it cannot be used for treat alkaline soil. Question 2. Calcium oxide is a metal oxide, is used to treat the wastewater from factory. Which substance is removed from the lime? Both calcium oxide or calcium hydroxide can be used for treatment of the acidic waste. Sulfuric acid will react. Question 3. Which process is used to make lime calcium oxide from limestone? Question 3. Yeah, that's right. D is the right answer. That's the thermal decomposition. Some uses of the limestone are given. Which numbered lines show the correct use of limestone? This one is 2. Question 4. What's the right answer? For making cement, limestone or calcium carbonate, so that's right. Making a lime, calcium oxide, that's also right. And added with hematite in a blast furnace, that's also right. Because for extraction of iron, we use limestone calcium carbonate so that it decomposes into calcium oxide and carbon dioxide. And that calcium oxide react with silicon 4 oxide and it will form calcium silicate or slag. So all the three uses are there. So 1, 2, and 3. The extraction of the iron in the blast furnace use a limestone or calcium carbonate. The diagram represent a lime kiln. What leaves at X, the furnace at X? So fuel A limestone is there. Here we are adding a fuel. We keep the limestone here, so it decomposes into calcium oxide and carbon dioxide gas is given off. Yeah, that's right. C is the correct answer. Calcium oxide. Substance X is used to treat the industrial waste. What is X and which type of reaction occur during the treatment? So calcium oxide, because the basic oxide and it is neutralizing the acid waste, so A is the right answer. The diagram shows a kiln used to manufacture lime. Which row identify X and Y? What is X? I want participation from everyone. So, because X is basically adding calcium carbonate that decompose into calcium oxide and result in a formation of carbon. The gas burner are basically to produce the heat energy so it can burn and increases the temperature. Question 8. The diagram shows the soil pH range which a vegetable grows well. The pH of the soil used to be 5.5. Why is the lime added to a soil before planting the vegetable? So lime change the soil acidity. It's not a catalyst, it's not indicator, it does not supply because it does not have nitrogen. So how it supply nitrogen? So B is the right answer. When a compound X is heated, it changes the color from green to black. Compound Y is formed and a gas is given off, turned lime water milky. This compound is a colored compound. If the colored compound is there, so it cannot be group 1, 2, 3 compound. It should be a transition element. So either B will be answer or C will be answer. But it is giving a lime, turning a gas given off turned lime water milky. So it means it should be a carbonate. So it is actually copper carbonate. Copper carbonate decomposed into copper oxide plus carbon dioxide. The carbon dioxide will turn lime water milky. Copper oxide is black in color and copper carbonate is green in color. So C will be the right answer. Copper carbonate, because what happened? A compound X is heated. So we heat compound X. It changes from green to black. A compound Y is formed and a gas is given off which turn lime water milky. So a gas is given off which is turning lime water milky. So this confirms that the carbon dioxide is there. And which substance on heating form carbon dioxide? So carbonate on heating gives carbon dioxide. But which carbonate is this? Calcium or copper? So it should be copper. Why? Because it is a colored compound. Calcium group 1, 2, 3. Their compounds are white, solid. That's why C is the right answer. Is it clear? Again, a similar question. The diagram shows a kiln used to heat the limestone. What is the product and what waste gas is formed? So the product will be calcium oxide and the gas is carbon dioxide. So B is the right answer. Uh, in which process carbon dioxide is not formed? Fermentation, it's in organic chemistry, it form carbon dioxide. No, it's not, it cannot be B. B, the fermentation means when actually glucose, the sugar solution, form carbon dioxide and alcohol. Burning of a natural gas, when you burn the fuel, a hydrocarbon such as methane, that also give carbon dioxide. Burning of the fuel give carbon dioxide and water. So this also produce carbon dioxide. Heating a lime, lime means calcium oxide. So heating a lime does not produce, because lime does not change, limestone changes. So heating a lime does not produce carbon. Respiration also, like what happened in respiration? So glucose C6H12O6 plus O2 gives CO2. I'm not balancing the equation. CO2 plus H2O. So all the three processes are emitting out carbon dioxide. Heating a lime, which is calcium oxide, does not produce carbon dioxide. It's not a limestone, it is a lime. Lime means calcium oxide. Question 12. Which process does not produce carbon dioxide? Yeah, that's right. Acidic base. Then question 13, carbon dioxide is produced when dilute hydrochloric acid react with. So question 13, because when carbonate react with acid result in a formation of salt water and carbon dioxide. So C is the right answer. This is the same question repeated. Two industrial processes that involve heating are extracting iron from its ore using a blast furnace and making lime. In which of these processes calcium carbonate is used? Extraction of iron, we use calcium carbonate. What is the use of the calcium carbonate? It is used to remove the impurities such as silicon by forming a slag. Because what happened, calcium carbonate due to heat decompose into calcium oxide plus carbon dioxide, and then that calcium oxide which is formed reacted with the impurity sand, silicon 4 oxide and forms slag or calcium silicate. So it is used in extraction of iron. And for making a lime, yeah, lime means calcium oxide. So A is the right answer. In this question, a quick lime or lime, which is calcium oxide, is made by heating a limestone in a furnace. The reaction does not come to equilibrium. Equilibrium means like there's no reactants form a product, but it is not coming in equilibrium. Suggests why the conversion of calcium oxide is complete. So what is the reason why the calcium oxide which is formed here, it formed completely? Like why it does not form calcium carbonate back? The reason is that, look, for formation of the calcium carbonate back, like calcium oxide react with carbon dioxide to form calcium carbonate. But why it is not forming calcium carbonate? Because what happened when the forward reaction occur, calcium oxide and carbon dioxide is formed. Carbon dioxide is a gas. So this gas will escape. So as the gas will escape, so there is no carbon dioxide left to react with calcium oxide. That is why the reversible reaction will not occur. So you will mention the carbon dioxide will escape. So the reversible reaction cannot occur. Calcium hydroxide or slake lime is made from calcium oxide, right? Equation. So the equation for this, calcium oxide react with water and it will form calcium hydroxide. Then calculate the maximum mass of calcium oxide which could be made from 12 tons of calcium carbonate. This part is related to stoichiometry, the moles. So we will not discuss right now. This is related to stoichiometry. So that's why I'm not discussing. In part D, the limestone is used in agriculture to reduce the acidity of the soil or for desulphurization of the flue gases in power station. Most crop thrive in soil whose pH is close to 7. Calcium carbonate, which is insoluble in water, and calcium oxide, which is slightly soluble in water, both are used to reduce the acidity of the soil. Suggest two advantages of using calcium carbonate for this purpose. So what is the advantage of using the calcium carbonate for the treatment of the soil? So first advantage, it is insoluble. So does not wash away. So the first advantage, it is insoluble. And the second advantage, excess of calcium carbonate does not make soil alkaline. Yeah, so it does not make the soil alkaline if you use excess or more than enough. Explain the chemistry of the desulphurization of the flue gases. It's of 3 marks. Like basically you have to explain how these gases are being removed. So what happened in desulphurization? So basically desulphurization, the flue gases contain sulfur dioxide, which is acidic, react with, we can use calcium oxide for this purpose as well, or calcium carbonate, react with calcium carbonate to form a salt or sulfide salt of calcium. So these flue gases, they mainly contain sulfur dioxide, that's 1 mark. Then react with calcium carbonate, that's a 2nd mark because one is acidic. So 1 mark is for mentioning flue gases contain sulfur dioxide. 2nd mark is for mentioning the sulfur dioxide is acidic, that's why it reacted with calcium carbonate. And the 3rd mark, it neutralize. You can also mention the last term, neutralization occur. Or it react with calcium carbonate to form a salt of calcium. Give one other use of calcium carbonate. So what is another use? Already you cannot mention the use which they mention already. So you can mention it is used in a blast furnace, also used for manufacture of cement, for treatment of acidic river. It can be used for making chalks. So these are the questions related to carbonates. Is it clear? The topic carbonate? Any doubt related to the class today? So I'll end the session and share the recording with you.